Hello everybody, my name is Thomas Halkier. I'm heading up a company called NeoCortec. We are based in Denmark, Copenhagen. And in NeoCortec, we are only focusing on one thing, and that's our NeoMesh protocol stack. It's basically a piece of software. It implements a mesh network. It's designed to be very scalable. We can have thousands of devices in the network. It's highly reliable. And then it's very efficient, meaning that it's battery powered. A little bit of a history with NeoMesh. Maybe most of you are not so familiar, but we've actually been into the market since 2014, where we introduced the protocol in our own modules at Electronica in Munich. Using regular FSK modulation. Then later on in 2021, we started licensing the stack on its own, working with selected OEMs to put the software stack directly into their hardware, working on different SoCs and chipsets. And then actually, since last year, we've been working with the LoRa physical layer. So this actually means that meshing on LoRa with NeoMesh actually is a software protocol stack that brings more than 10 years of maturity into it. So even though it's a new introduction for the LoRa community, it's a very mature technology. So just real quick, comparing the traditional LoRaWAN with the meshing setup. So probably most of you are familiar with how the LoRaWAN network operates. So it tends to be a fairly costly gateway architecture. You do have the reliance of a back-end system with network servers, and it becomes a single hop communication from the device onto the gateway. With the mesh setup, we actually can have a very low-cost gateway. I'll come back and explain what that means. We don't require any back-end. We don't have any, let's say, need to connect with a cloud or anything like this. We don't have to have a network server. And then we can route across multiple hops in the mesh. So that's sort of the main difference between the mesh approach with LoRa and the WAN approach with LoRa. So, and then diving into the details of NeoMesh, how does that then compare with other mesh stacks out there? You're probably familiar with Zigbee, Thread, BLE mesh, and those type of technology. We call them legacy mesh technologies, and the reason being that most of them are actually working off the same core principle of having dedicated device types. You have usually some sort of a coordinator who is responsible for organizing the network, who becomes neighbor with who, and so on. Then to extend the network from the coordinator, you have routing nodes. And then finally, you can have end devices that can be low power. They have to be within the range of a coordinator or a routing device. So routers and coordinators are not low power. They have to have mains power, whereas end devices, they can be low power. With NeoMesh, we've done it very different, actually. We only have a single device type. All of them are fully functional devices participating in the mesh. They can route data. The coordination of the network is completely decentralized, so all the devices in the network participate in the coordination and the setup of the network. It happens as a real-time background activity. And then finally, it's a time-synchronized protocol stack, meaning that the devices will go to sleep, wake up at predefined schedules, and communicate with each other and go back to sleep again. And this way of organizing the activity pattern in the network actually means that all the devices can be really low power. And really low power means many, many years on battery. Mesh on LoRa is also supporting the global frequency bands. Right now we have implementation at 2.4 gigahertz, 868 for Europe, 915 for the US, and we also have a profile for the 865 band in India. And all of this is basically complying with all the regulations. One of the tougher ones being the duty cycle restrictions that you have here in Europe. So just real quick about how the network is actually operating. When I say that it's a time-synchronized network, that actually means that we have what we call scheduled transmissions. So each device will wake up at a predefined schedule and transmit. its neighbors will know when that's about to happen and wake up and listen for that transmission. So those schedules transmission activities between the devices we use as a sort of a backbone activity in the network. We keep the devices in sync with each other. We distribute routing information that allows us to route through the mesh across many hops. And then it finally is also the vehicle to transmit payload data. So I basically drawn up here how payload travels through the network. So it goes without saying that one of the trade-ins that we do to get low power is latency. So latency through our mesh can be fairly long, but some applications don't have a problem with that. So it's a balance between latency and current consumption, essentially. So yeah. So just to talk about what is now available. So as I mentioned, the technology has been in the market since more than 10 years now. What we introduced actually at Embedded World this year was the first commercial available module together with our partner who has a booth right here called Mbit. They work out of Italy and they have a long experience in doing LoRaWAN modules amongst other things. So they have now a module available. It's a multi-protocol and multi-band module. So it does regular LoRaWAN. It even does wireless M-Bus and others. But it also features the NeoMesh protocol stack. So with this, actually, you have a module that can operate on 3 frequency bands: 2.4, 8, 6, 8, 9, 15. It does support the LoRa modulation. It can also do GFSK. All pre-certified. Their offerings also include an evaluation kit and a fully compatible gateway design. So basically, with Mbit, you get everything you need to integrate NeoMesh into your product. Our core business is our software, obviously, so we also want to license the software. It's a fairly low memory footprint stack. We fit into less than 100 kilobytes of flash memory. We work across a fairly wide variety of MCUs. We are agnostic to the physical layer, so right now, well, previously it was mostly FSK, now it's also LoRa, but essentially it could work off any physical layer. We do provide all the services to help our customers integrate the stack on their specific hardware, and also we've been working on customization efforts on the stack to fit a certain application. I did say that it's a network that doesn't rely on a backend. It doesn't have to have a gateway, but of course, in many cases, you do want to have some sort of a gateway that can get the payload data out from the mesh and into some other system, maybe a cloud system of some sort. So what we are offering is basically an open source gateway software design. It works on both Linux and Windows computers. Very low memory footprint and CPU requirements, so we have something on a booth running on a Raspberry Pi, works fine. And it basically allows you to integrate the system of NeoMesh with the rest of the world. And the thing to keep in mind is that a gateway node in NeoMesh is no different from all the other nodes. It doesn't have a special role to play other than being sort of a bridge between the NeoMesh and some other system. And you can have multiple gateways in a network if you want to. Since this is a very mature system, of course, we have a fairly big portfolio of tools that helps your development. Essentially, the implementation we've done now with LoRa, from a protocol interface point of view, APIs and such, is exactly the same as what we've had since 10 years now. So all our development tools for PCs and for Linux remains the same. That allows you to basically set up, configure the modules or the stack. It allows you to start sending payload data and receiving payload data, start to monitor the network, how it operates, and it actually will take you all the way from the first, let's say, interaction with the technology all the way to manufacturing, essentially. So real quick on use cases for NeoMesh, because why do we need a mesh instead of a LoRa in a way? We talked about the gateways being cheaper. We have the multi-hop capability. So think about cases where it becomes impractical to maybe deploy a lot of LoRaWAN gateways. It could be something like underground mining. It could be deep indoor. It could be forestry. If you have to have something that measures whatever parameter in a forest, maybe you don't want to deploy gateways all the way there. So there are many applications, and I actually took one interesting note from Vink's presentation tomorrow morning when he was asked, or he was saying about what is actually the main vertical that LoRaWAN is actually focusing on, and he was showing, I can't remember how many, but all of them shared the same, let's say, percentage of the coverage, and we sort of have the same thing with our stuff. It's not like we have one key application space where we have a lot of traction. It's basically spread across a lot of different, let's say, application areas. So I brought with me a few examples for you to look at. This is a Swedish-based customer of ours who do energy optimization of buildings. They do that by measuring the temperature of all the rooms in a building, potentially many hundred rooms in large buildings. And then they create a model of the building, how that reacts to the outside temperature. And then they can use that to, on one hand, optimize the setting of the radiators in each room, but then also to adjust the heating profile of the central heat source of the building. So, but the reason why they like to use NeoMesh is that when they are installing the system, they want to be quick in and out of the building. So here's one example where they did 90 sensors, so that's 90 rooms in a building. And they had 2 people for 3 hours there installing the sensors, basically gluing the sensors, sticking the sensors to the wall, putting the gateway in the basement next to the heat exchanger, and then left, and then data was flowing. So that's actually another benefit with what we are offering. It's really easy to deploy and to get operational. So that's I would say a typical case for NeoMesh. This one, very low data rates. They get 10 years of battery lifetime on their sensors, 2 AA batteries. So a good a case for NeoMesh, I think. This one is completely different. It's an evacuation system for cruise ships or passenger ships, where you are monitoring the process of people escaping through chutes into the lifeboats. So this is different in a way that it's actually requiring a fairly low latency, but they need the meshing because the chute comes across the let's say the side of the ship, which is usually made from metal. So they need something that can reach, let's say, over the side of the ship. It's at 2.4 gigahertz, this one, because it needs to operate internationally. They think they get 7 years of battery lifetime on the system. Not such a big network. Maybe they only have, I don't know, 12, 15, 20 devices in the network, but it's a nice application because when sort of the evacuation happens, the system needs to be up and running real quick, and they basically just deploy the system and it has to work. Another case, which is the harvesting of maple syrup, or I guess the juice which comes from the maple trees that then becomes syrup. They do that by having vacuum lines in the trees spread across the forest, and they want to monitor those vacuum lines. So they have actually thousands of sensors installed that monitor the vacuum level, and if something breaks or something doesn't work, then they can detect it and fix it. It's a fairly short harvest season, so they need to make sure that it's up and running 24/7 when they do it. So they use NeoMesh to basically collect the values from the sensors. And then finally, this was actually our lead case for the licensing of NeoMesh. Honeywell were the first ones who integrated our stack into their fire detection devices for commercial real estate. So of course this one we're very happy about. It's a network consisting of 1,000 detectors that operate in a mesh, very reliable. As you can imagine, it has to be for this kind of application, and it also has to run very long on the battery. So as you can see, all of them were quite different cases of NeoMesh, and I'm sure you guys have ideas on your own for how to use it. I'm always surprised when new customers come along with their ideas, then we will find a way to make NeoMesh work for that. So We are here at 2 booths. We are down there at MBIT's booth, where we are showing the modules that I mentioned, but we are also together with Endrik, who has a booth right over here. Endrik, I didn't mention too much, but they actually are cool in the way that they build real products with this. So they have sensors, gateways, everything you could imagine, and they will help you on your design journey also. So thank you.
Thank you, Thomas.